Hello, my name is Vitas, and this is my assistant Uma. Today I would like to tell you about the houseboat I designed. Okay, let's get started. So, now you can see three sausages. If I may call it that. Joined together from separate pontoon segments. It will be trimaran. And here we can see three different types of pontoons. Front element. Lots of middle elements. This is how one looks. And there is a rear element at the end of each formation, which smoothly completes the sausage as I call it. Depending on the purpose, each pontoon segment has a corresponding shape. We see that the front segment is made to split water well. That's obvious. The middle segment. Here I will pull it to the side. So, the middle segment is an object of an elliptical profile. And the parts made on it are intended for fixing the deck structures. Again, the end element is made to smoothly complete the pontoon assembly. This is a beautifully shaped end. Not just that straight cut, but it beautifully forms the whole sausage. Also, we can see the holes for the bolts in the ears of the pontoons. Here, if you imagine, beams will be fastened. Here, here and here. They will be fastened with screws. Also, a metal profile will be placed at the bottom. Aluminum. The elements will be connected to each other by screwing the U-shaped profile with screws. These pontoons are manufactured by a company called Roto Plus. The factory is located near Klaipėda, Lithuania. In the description of this video you will find a link to their website. I also have their catalog here. I will make this window bigger. These are ABC series pontoons. Again, here we see front, middle, rear. We can call it instruction. Technical data. User Guide. Here, each segment is presented in more detail. Here is the front segment, its length, width, height. Is 98 centimeters times 98 centimeters, height 85 centimeters. Here are all the other details, weight and so on. Again, the middle element. Length 80 centimeters, width 98 centimeters, height 85 centimeters. And the rear element. Length 78 centimeters, width 98 centimeters, height 85 centimeters. I will use foamed elements. This means that they are made of polyethylene material and additionally filled with polystyrene foam inside. This gives an additional security effect. Let's say, if an element is damaged, it will not fill with water so easily. And only gradually it will lose part of his flotation. Because polystyrene foam absorbs water quite slowly. It is written here, the absorbency of a damaged pontoon filled with foam. Short term, up to 4% by volume. Long term, up to 10% by volume. This means that the element practically does not lose its buoyancy when it is damaged. The front element is not foamed. I'm not sure about the rear, but the front element is not foamed because if it is damaged, it could be restored to its original geometry by heating. And I won't foam a few middle segments because they will be used as tanks for water and possibly sewage. There are several possible pontoon colors. I choose. Oh, well, here are even more detailed dimensions. If anyone is interested. Maximum immersion is recommended here. At a load of 125 kilograms per pontoon, it plunges 41 centimeters. And this is the maximum recommended immersion. When the height of the pontoon, excluding fasteners, is 75 centimeters. Here you see the dimensions of the middle segment. Also its maximum recommended immersion. A maximum immersion of recommended 41 centimeters when load is 220 kilograms per segment. I will try to follow these recommendations. Again, the dimensions of the rear segment. Here are various recommendations. I'm looking for colors. This is where the user guide begins. Apparently there are no colors in this document. Well, does not matter. There are several possible colors. Black, blue, white. I choose dark gray. For me, according to my whole color idea, this option is the best. Let's return to my sausages. Here, as I mentioned, is trimaran. The side sausage consists of 15 middle segments and plus front and back. That will be a total of 17 segments. The middle sausage is slightly shorter. It is -2 segments. That means there will be 13 middle segments and front and rear segments. Total 15. Such a number of segments of trimaran allows me to achieve about 7,000 kilograms of lifting capacity. Here is another document from Roto Plus. Here are the prices of the platforms they produce. But what interests me is the lifting capacity of pontoon platforms with ABC pontoons. These weights can be safely loaded. They give 15 pontoons in a row. Here is a trimaran, 3.5 meters. As much as the width of my pontoon without the side bridges. So, if in a row of 15 pontoons. Here we mean the outer row. The lifting capacity is 6,734 kilograms. Meanwhile, I have 17 pontoons in a row. That's why I don't do exact calculations here, but from this number you can see that the number of segments I have chosen, combined into 3 sausages, will hold about 7,000 kilograms. I'm not going to achieve that much, but to imagine the lifting capacity of my pontoon platform I still need to think about it. Because it would just be unwise to ignore it. You may be wondering why the middle sausage is shorter. This is because this cavity is left to hang on the fuel tanks. They will be hung on the platform frame, on beams connecting the pontoons. More should be said about joining the segments of pontoons. As I mentioned earlier, at the very beginning of the work, the inverted pontoons are connected by an aluminum profile, which is tightened with bolts. Well, I'm not showing bolts here. This project isn't that detailed. But there are holes here. Extremely corrosion-resistant aluminum ENAW 5754 is used here. This is the aluminum grade. For obvious reasons, because it will be in the water all the time. As far as I understand, such aluminum is resistant not only to fresh water but also to salt. My houseboat will obviously be mostly in fresh water, but in any case it is recommended to use such aluminum.
Dar toks pastebėjimas, tokių lankstinių, tarkim, U formos.
And another observation, I did not find such already manufactured U-profile products from this aluminum class in Lithuania.
Jų nusipirkti aš neradau, bet galima pirkti šito aliuminio lakštų.
But you can buy sheets of this aluminum and the same company Roto Plus folds them with a machine. So these profiles can be ordered together with pontoons. As I mentioned, you see the beams here. Pontoon sausages connecting beams. Wooden beams were used here. I chose wooden beams because well, maybe we should talk more here. Of course, in terms of durability, rigidity of the platform, stability of the structure, it would certainly be best to use the same corrosion-resistant aluminum profiles. But I chose wood because I'm designing this houseboat in a way that allows you to spend time and maybe even live in the winter. This means it will be properly insulated. I wanted to make the ship no higher than necessary, as it also affects the handling, transportation options on the truck. So I chose to install a significant portion of the insulation between these load-bearing elements. In other words, fill this gap with thermal insulation material. If I used aluminum profiles in this situation, all this principle would be meaningless because metal is a very good cold conductor. There would be cold bridges. So the most logical option for me was to choose wooden beams. It is important that the gaps between the wooden beams will be filled with polyurethane foam or polyurethane panels by blowing the gaps with foam. And simple wooden constructions must be ventilated to prevent mold growth. Also, my desire is to cover the bottom with fiberglass, which further increases the enclosure of the structure. So in this situation, it makes the most sense to choose glued timber beams. Glued wood is also better in its properties. Also, its bearing capabilities are much better. Its design capabilities are much better. Also, the mechanical capabilities are much better.
tos nešančios savybės daug geresnės, ta prasme konstrukcinės savybės daug geresnės, mechaninės daug geresnės. Tai šituo atveju čia, žinoma, jinai ir gerokai brangesnė, bet man atrodo, kad
Of course, glued timber is also much more expensive, but it seems to me that this platform frame is the backbone of the whole ship, if you can call it that. The foundation, if you make an analogy with buildings. I think I shouldn't be saving in this place. Yes, that's why I chose glued wood beams. As for the size of the platform beams, where the beams are under the house, the dimensions are 5 times 10 centimeters. Here I made higher beams under the decks 5 times 15 centimeters. The different height of the beams is because the cabin has a thick floor due to insulation and other layers, and the deck is just a relatively thin slab. So as not to get a big height difference between the deck and the floor of the house, I made these beams higher. But it's a matter of taste. It's so much nicer to me. What else should be mentioned here? I would like to reiterate that all these beams, together with the insulation, will be covered with fiberglass both from the bottom and from the sides. Like, by the way, the whole cabin. Here we see the perimeter of the platform. It is also formed from glued wood. It is needed to join the beams on the perimeter. This gives some stiffness to the structure. If you noticed, there are also longitudinal joints in the middle of the structure that give the structure extra rigidity, to prevent the platform from distorting. That perimeter is also required for the attachment of certain elements. And if more precisely due to the fastening of the bridges that will be on the sides to bypass the volume of the houseboat outside. It should also be mentioned that I am an architect, not structural engineer, but through my certain, perhaps not very short, experience, I have a certain sense of bearing qualities. How optimal this structure is? It's a separate question, but if this structure will hold, I have no doubts. If I build this version of the houseboat anyway, this design will be reviewed by the structural engineer as well. Also, a ship design specialist who will review all aspects of buoyancy, wind impact on ship size, and so on. What belongs to be reviewed in the design of the ship? As I mentioned, all of this structure, including the insulation, will be covered with fiberglass.
Taip, čia jau matome šoninių tiltelių struktūrą. Ji yra
Here we see the construction of the side bridges. It is made of aluminum. Because
viena priežastis dėl to, kad šita struktūra turi būti
the first reason is because this construction has to be light. Second, for aesthetic reasons, the structure will be visible on the outside, it will not be covered. With aluminum, we beautifully form the perimeter of the platform. The same corrosion-resistant aluminum is used here. The following elements are made from it. Maybe I could call them cantilever beams. And these beams will attach directly. Let's go back to why the perimeter of the platform is needed. Straight to the beam. Maybe you can see better here. Straight to the beam and to the perimeter. Through the aluminum perimeter profile directly to the end of the beam and the wooden perimeter. Here with 2 or 3 bolts. Why are elements fastened in this way? Imagine if we chose another method, then we would have to fasten or weld the bridge structures to this perimeter aluminum profile. But here gets a pretty big load shoulder. When people walk on bridges. And a person can weigh 100 and over 100 kilograms. This will result in a very large bend and such an attachment may not withstand. At least in my understanding. If we fasten it to the end of the beam and the perimeter of the platform with long bolts, it will be a stronger assembly. That's all today. Watch more in the following videos. If you liked this video, press like. To see more, click the subscribe button and the bell next to it. Thanks and all the best.